Hello guys, in this video we'll be doing physical sciences, which is the paper 1 or part 1, which is the physics. Firstly, we will focus on the Newton's laws. Then after the Newton's laws, we'll decide whether we go to the momentum or the vertical motion. But firstly, let's focus on the Newton's laws. Before we can continue, you know what you gotta do. Please, down below, you know what to do. Press that subscribe button and subscribe. Okay, so this is a first law, and this side we have the second law. So what does first law tells us? First law states that the object will continue. The object will continue moving. That's moving on a straight line. This is straight line. I'm sort of my writing, unless there is a net force acting on it. What is that? What does that it refers to? It refers to the object. So mathematically, how do we present this? So if we were to present this mathematically, we were going to write F net is equals to 0. But some textbooks gonna represent this F net as sigma of F equals to 0. But I prefer this way. Then coming to the second law. I know I haven't explained this yet, but I wanna firstly write both of the definitions first. So what does second law tells us? Second law states that when a net force acts on an object, the object will accelerate in the direction of a force. Will accelerate in the direction of a force will accelerate in the direction of a force with the acceleration that is directly proportional to the force, and inversely proportional to the force. I'm sorry, to the mass of the object. This says that when a net force is acting on an object, the object will accelerate in the direction of a force with the acceleration that is inversely, that with the acceleration that is directly proportional to the force and inversely proportional to the what? To the mass of the object. Then this mathematically is represented by F net equals to MA. I don't want you to confuse this, to confuse yourself. F net equals to MA means second law. F net equals to 0. F net equals to 0 also means second law. So let me first tell you something. Do you see this? I've got this object here. We will be using this object to show in the form of some sort of an experiment. So looking at this object, is this object moving or not moving? What is your answer on that? Okay, this object is at rest. This object is not moving, yes, but at the same time this object is moving. As if standing here, it is moving, but you know what, it is moving with the velocity or with the speed of 0. That means this object is moving with a constant velocity, with a constant acceleration. Hence now on the first law, because there is no force that is acting on this object, then the acceleration is equals to 0. So if we were to substitute acceleration here, then this object, this was going to be m times 0, causing this to be F net equals to 0, and because there is no force acting, then it's equals to 0. So I think for the first law, this is all you need to know. But let me tell you one thing. On the question paper, they will kind of mix all these Newton's laws in one question. So your mind gotta be a bit flexible when working with these Newton's laws, because this is a very important chapter. Yes, I do agree that it is easy, but you know what? It is also tricky. So coming to the second law, what does second law tells us? Second law tells us that when a net force acts on an object, the object will accelerate in the direction of a force with the acceleration that is directly proportional. So firstly, what does the term means? What does the term directly proportionally mean? So this is the relationship between the acceleration and the force. It says that the force and the acceleration have a directly proportional relationship. If we were to express this in the form of symbols, I will tell you next time, not now. Let me quickly finish this first. So, what does it mean when it says directly proportional? If the force is increasing, then the acceleration will also increase. Look at this object. This object, let's say I'm pushing this object with the force that is 2 newtons. Okay, can you see the acceleration? This object will say that it's moving when I'm pushing it with the force of 2 newtons. Then it is moving with the acceleration of 0.2 meters per second, I'll say. Then now I am increasing my force. I am pushing this object with with the force of 5 newtons. So this is my 5 newton force. What happens to the speed of the object? Can you see that? now the acceleration increases. The more you increase the force, the more the acceleration increases. And the more the acceleration increases is also the more the force increases. Okay, now what happens to the mass now? Coming to this part is done. Now directly proportional to the force and inversely proportional to the mass of the object, to the mass of the object. Now I have these two objects. This let me check. This is let's say they are not written, so let's say this is 300 grams. This is 300 grams. And this now, this is a 1 liter. This is a 1 liter. This is a 300 milliliter. So their masses are not equal. They cannot be equal because this is a 1 liter and this is less than this. So if I am applying the force of one newtons on this, and also applying the force of 1 newton on this, what happens? Let's check. So this has a greater mass compared to this one. So applying this force of mine, which is estimated to be 1 newtons, then let's check. Can you see that this is moving with a force of 1 newton? Then let's apply the same force on the second object, which has a greater mass compared to this one. The force is 1 newton, but now the force is constant. The force applied is the same, but only different masses. So now pushing this with this 1 newton force, then look at it. Can you see? Can you see its velocity? It's moving too slow compared to this one. Then this is to prove that if the more you increase the mass, the more the acceleration will decrease. Then the more we decrease the mass, the more the acceleration increases. Then now, to prove this with calculations, because everything done in physics must be proven with calculations. So now let's solve for acceleration. If we want to solve for this acceleration, we have to divide by m on both sides. We divide by m here and also divide by m to balance our equation. This and this will divide each other, causing this to be A equals to force over the mass, F net. So now I'm not going to do this. So even the relationship tells you have what happens to the number when you increase the denominator. Whenever you have a bigger denominator, then you are going to have a small answer. Whenever you have the smaller the numerator, the bigger the final answer. The smaller the denominator, the bigger the number you get. Yes, the smaller the denominator, the bigger you get, and the more the denominator, then the smaller your number gets. To prove this, let's say we are calculating the acceleration. We have the force. Let's say our F net is equals to 3 newtons. I forgot my calculator today. Then let's say mass 1 mass 1 is equals to is equals to 1. M1 is equals to 1, and M2, which is the mass of the mass of this. Let's assume that the mass of this is equals to 1 kg, and the mass of this is equals to 2 kg. Then let's, because we don't have a calculator, let's allow this force to be 2 newtons, so that it is not gonna complicate our lives. Then this is the equation for the acceleration. It's A equals to F net over m. So now let's substitute the force. The force is constant for both. Then for A1, which we're gonna substitute this m, which is m1. Then we're gonna have our 2 newtons as the numerator, all divide by 1 kg. Then this ends up being being 2 meters per 2 seconds. A1. Then coming to A2, now we're going to substitute this mass, which is M2. So I don't wanna go down too much. So we have A2 equals to F net over M2. Then this is equals to, what is our F net? It's 2 newtons. It's 2 newtons still, all divided by 2 kg now. All divided by 2 kg. Then this is equals to, what is 2 divided by 2? This will cancel, therefore we end up having 1 meter per 2 seconds. So can you see now, the more we increase the mass, the more the acceleration decreases, to prove this relationship, this proportionality that is stated there. So let's quickly wipe the board.